Today we're going to talk about linear, non-linear equations. When we talk about linear equations, this is something that we've already done. We need to make sure that it's a straight line. So the first thing I want you to do is I want you to take your foldable and I want you to fold it in half. And then just cut down, make sure you're lifting up your paper. You're only going to cut the top so you have two flaps or two doors. One talking about linear and then the other one talking about nonlinear. We are going to graph our linear equations. So let's talk about this because this is something that we've already done. We want to be able to graph this by using our slope-intercept form. You can match up your y equals mx plus b. You're looking for your m, which is the slope. In this case, it's 3 or 3 over 1. And your b is your -2. This is where you're going to start your line on the y-axis. -2, we're going to go down from the x line. We're going to go down to 1, 2. This is your -2. Positive slope, so we're going to go up 1, 2, 3 over 1. Here's our first point. We're going to go up again, up 1, 2, 3 over 1. 3 points is plenty. You could do one more, meaning you can go down and to the left. And then I want you to take your ruler or a straight edge and go ahead and connect your points. I can clearly see that this is a straight line. All right, let's do number 2. Same thing, we're going to match up our m and our b. Our m is 1/2. Meaning our rise is 1 and our run is 2. And our b is 3. So starting on the y line, we start at the number 3. 1, 2, 3. It's a positive slope, so it should look just like number 1. So we're going to go up 1 over 1, 2. Up 1 over 1, 2. If I can't go up and to the right, I can go down and to the left. So down 1 over 1, 2. And again, I like 4 points, so this is plenty. Go ahead and connect your points. And as you see, it does make a straight line. All right, let's look at number 3. My m, in this case, is -2 over 1. So we have a negative slope. It's going to go the opposite direction of number 1 and number 2. And we're going to start at a +4. So we're going to go up 1, 2, 3, 4. Negative slope. So I can go up 2 and to the right 1, or down 2 and to up 2 and to the left 1, or down 2 and to the right 1. I'm going to go down 2 more and to the right 1, just so I have those 4 points. Take that straight edge. It is still a straight line. Another indicator, which we've talked about before, is that I know it's going to be linear when I'm looking at an equation because it's to the first power. Our x is to the first power. I can hear with this number 4, same thing, my x is to the first power, so I really know that it's going to be straight. I know you notice there's something missing. I can put in front of this x a 1 to help me. So my slope in this case is 1 over 1. And my b, or my y-intercept, is -3. So we're going to go down 1, 2, 3. That's where we're starting our line on the y-axis. And now let's go up 1 over 1. Up 1 over 1. Up 1 over 1. I think that's plenty. These are all straight lines, so they are all linear equations. Okay? Let's look at this last one, number 5. It says, the temperature at dawn was 52 degrees and increased steadily 3 degrees every hour. Write an equation and graph the relationship below. So the first thing we need to write an equation. So my b is that initial starting point, or my y-intercept, which is the 52 degrees. All right, and then every hour it increased. So it's a positive slope, and that is my m. Okay, we can use that every to, just like if we were saying per. All right, so we're going to write our equation. Y equals 3x plus 52. The next thing we're going to do is we notice it's going by twos. So you can either solve this by going y equals 3 times 2 plus 52. 3 times 2 is 6. 6 plus 52 is 58. So my first point, of course, if you notice it's going up by 5s each line, is starting at 52. So right between that 50 and 55. And then at 2, it's going to be 258. So just above the 55 and below the 60. We can go again to the 4. Y equals 3 times 4 plus 52. 3 times 4 is 12. 12 plus 52 is 64. So this one is 464. So we're just going to go below that 65 line. Let's do one more. Y equals 3 times 6 plus 52. 3 times 6 is 18. 18 plus 52 is 70. So 670. I'm going to go ahead and take my straight edge and connect my points. This again is a linear equation. It is straight. All right, let's talk about nonlinear. Nonlinear means that it's not going to be a straight line. So let's start out with our equations. I told you before that as long as the x is to the first power, it's going to be straight. If we notice here, this is to the second power. When I see that it's the second power, I know that my equation is going to end up making a u on the graph, or what we call a parabola. I'm going to set up my function table so that I may solve and find some points to graph on the line. Let's use those famous x's, -2, -1, 0, 1, and 2. The next thing that I would like you to do so you can separate your numbers is go ahead and draw some lines here. I'm going to do the same thing straight across so I'm ready for the next one. That way it looks more like a function table and you don't get your equations mixed up. Okay, so I'm going to plug in my x's. In this case, I'm going to square my x's and then add them to 1. So just go straight down, say 0 squared plus 1, 1 squared plus 1, and 2 squared plus 1. -2 times -2 is a positive 4. 4 plus 1 is 5. -1 times -1 is 1. 1 plus 1 is 2. 0 times 0 is 0. 0 plus 1 is 1. Now this is where you should see the -2 and the -1 should repeat at the positive 1 and positive 2. 1 times 1 is 1. 1 plus 1 is 2. See how they repeat? 2 times 2 is 4. 4 plus 1 is 5. Now we're going to graph. We have a -2, positive 5. 1, 2, 3, 4, 5. A -1, positive 2. 0, 1. 1, 2. And 2, 5. Basically, it makes a mirror image on both sides of that y-axis. And you have your parabola or u. All right, let's look at x cubed, meaning to the third power. We're going to use those same famous x's. In this case, you are going to multiply it 3 times. We've talked about this before. It's going to make an S or a snake on the graph when it's to the third power. All right, we're going to start out with saying -2 cubed minus 2, -1 cubed minus 2, 0 cubed minus 2, 1 cubed minus 2, and 2 cubed minus 2. -2 times -2 is a positive 4. 4 times -2 is a -8. -8 minus 2 is a negative 10. So my first point will be negative 2, negative 10. All right, negative 1 times negative 1 is 1. 1 times negative 1 is a negative 1. Negative 1 minus 2 is a negative 3. So my next point is negative 1, negative 3. 0 times 0 is 0. 0 times 0 is 0. 0 minus 2 is negative 2. All right, the next one, 1 times 1 is 1. Times 1 is 1. 1 minus 2 is negative 1. Notice it doesn't repeat like it did over on the squared one. The next one, 2 times 2 is 4. 4 times 2 is 8. 8 minus 2 is 6. So we have 2, 6. All right, let's start out by graphing. We have negative 2 and then down 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and we don't have a 10, so we're just going to put our point here. The next one is a negative 1, negative 3, negative 1, 1, 2, 3, 0, negative 2, 1, negative 1, and 2, 6. 1, 2, 3, 4, 5, 6. Notice it's going to make sort of a squiggly line, or what I said, a snake on the graph. All right? Okay, last one, number 8. It says a square tile. A square tile has a side length of x inches. The equation is y equals x squared. Gives the area of the tile in square inches. Graph the relationship between the side of the square and its area below. So because I noticed there's no negatives on my graph, I'm going to use the x's they provided, which is 1, 2, 3, 4, and 5. So we're going to do 1, 2, 3, 4, 5. And then I'm going to do x squared for my equation and find my y's. I'd like to break up my function table, so you may want to do the same. And you should notice that this is going to make a half a u because it's to the second power. All right, so you're going to come here, write parentheses squared, put a 1 inside the parentheses. Parentheses 2 squared, 3 squared, 4 squared, and 5 squared. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And 5 times 5 is 25. All right. We know that the graph is going up by 2's. Let's start. Our first point is 1, 1. So that's going to be between the 0 line and 2. Next one is 2, 4. Then 3, 9. So halfway between the 8 and the 10. Then I have 4, 16. And then my last one is 5, 25. So I'm just going to go right above the 24 line. I'm not starting at 0. I'm going to draw. And notice it looks a little straight, but it does have a curve. So this is a non-linear equation. All right, glue this into your IMN on page 44, and then you should be able to pick out linear and non-linear pieces from the paper that I provided you for the right side, page 45.